introduce another leader in the DevOps community. Collin is a software architect with Dutchie. I personally had the privilege of seeing some of the Dutchie team present their architecture, so I know you're in for a treat. Dutchie provides safe and easy access to cannabis and serves both consumers and dispensaries. And like Pulumi, was launched in the Pacific Northwest, in this case, Bend. So I know that weather is not Pacific Northwest weather.
No.
Because it's a little bit gloomier here. But he's going to talk about enabling Kafka adoption with Pulumi and specifically the Confluent Cloud. So take it away, Collin. Thank you.
Yep. Yeah. Thank you, everybody. My name's Collin. I'm working at Dutchie, everything he just said. This is sunny St. Petersburg. This is where I call home. Pretty much all of Dutchie is remote at this point. I think there are a handful of people in Bend, but everybody I interact with day to day is all remote. So let's jump right into it. Yeah, a little bit about me. I'm on this core technical services team at Dutchie. It's responsible for providing a technical platform to support 3 separate monoliths and enable the development of new services. Oh, and I just want to say that please hit me with questions as we're going. I've timed this and it might be a little tight, so get them in there. And I'll try to answer them as we go along. So anyway, we're basically a platform team. We're supporting these 3 monoliths. About a year and a half ago, Dutchie it was an e-commerce platform, and then they acquired 2 point of sales. So we've got a variety of monoliths, and so we're trying to create a common platform to put all of those on and develop new services in between. Our users are other engineers at Dutchie. Individually, I'm responsible for the adoption of streaming technology as part of this platform. And I have kind of done this work once before using Terraform at another organization, probably starting around 2019 is when that kicked off. So streaming is important, and one of the reasons that streaming is important is it helps us avoid building a distributed monolith. This is really just a bunch of services that are really tightly coupled, and one of the ways those services become coupled is through synchronous communication dependencies. And then streaming technology is then providing our alternative. It provides fast, resilient, asynchronous communication. And this diagram just kind of shows that really closely. These 2 services are coupled. If service B experiences a bunch of load, then service C experiences a bunch of load. And in the inverse, if service C has a bunch of latency, then service B is going to have a bunch of latency. And so they aren't really that independent at all. The other reason that streaming tech is important is it helps us liberate data from our legacy systems. So, like I said, we have 3 monoliths. Those are our largest and most valuable things. And they're also tend to be difficult to understand and modify. I'm not going to throw shade at anybody at our organization. It's all fantastic. But in my experience, when a project has grown to the scale that you've got, dozens and dozens of engineers working on it, it becomes a difficult thing to work with. So streaming technology includes the concept of these connectors, which are really like low-level database integrations between the streaming tech and a database. And then what that allows us to do is basically stream all the changes that are occurring within this kind of legacy service and get them out onto Kafka. And that supports data migrations and other asynchronous communication patterns with this old system. And, without a lot of work, we're just kind of standing up an appliance next to this big important thing that we've had forever and letting it go. So streaming is important, but streaming is also kind of difficult to adopt. First reason is you really never know who's going to be the first to adopt. It's also unfamiliar technology, so engineers aren't going to be aware of the opportunities and risks that exist there. And then generally, I've found, especially around streaming, a lot of cost and complexity concerns, just FUD. This is going to be expensive, this is going to be difficult, and it really doesn't need to be. So my advice here is to focus on creating opportunities and reducing friction. There's a trap here. If you associate the development of your streaming platform, if it's like attached to a product deliverable, then there's a good chance that product deliverable is going to get deprioritized, or maybe changes its implementation, or there are a bunch of things that could change, and that doesn't really need to change the implementation of your streaming platform. So it's very much like Field of Dreams. If you build it, they will come. Focus on creating those opportunities. Do outreach as the technology becomes available. Similar to that last point, if you engage people too early, then it kind of becomes this chicken and the egg thing. We can't use it until it's ready, and I don't know what I'm going to build until you tell me how you're going to use it. So um, as things become available, that's the point to start engaging with your users. And then finally, take on that early integration work with legacy systems yourself. Um, Again, the monolith, you end up with kind of this stratification of responsibility. People are responsible for front end, people are responsible for databases. You're probably going to come in and be responsible for producing change events out of those databases. And that's really the easiest way to get that work moving forward. So our goals here, I wanted to create a way for teams to own their own resources as fully as possible, self-service, reasonable guardrails, but really make it as simple and easy to use as possible. I wanted there to be basically no friction for adopters. They should be able to come in and get something going right away. For me, low operational overhead. I'm practically speaking the only person that is supporting this. So I'm one person, I can't do that much. So I'm looking for solutions that are require very little of me so that I can, do a lot of other things. And finally, we want to get that data out of the existing monolith. That's what we were talking about before. So get into the streaming provider a little bit here. We went with Confluent Cloud and Kafka. So Kafka is a really proven and featureful streaming technology. It might be a bit much to say it's the most mature, but it is. It has a really strong open source community, and like I said, it's really proven. Uh, Confluent is the largest contributor to open source Kafka. Practically what that means is they've got a lot of engineers on staff that are making PRs to open source Kafka and contributing features. It also means that Confluent has some advanced features because they essentially get to develop it first before they release it to open source Kafka. So we have a little bit of access to some things like tiered storage and other little advanced things. That makes it the premier fully managed Kafka solution. One of the other benefits here is I don't have any dependencies on any other teams or any other individuals within core technical services. So if I were to pursue a solution that relied on Kubernetes or maybe ran on AWS, I'd essentially be waiting for other people to finish their work before I could begin mine. And this allowed me to move forward without really depending on anybody else at all. And finally, it's really, really low effort. Um, I can't stress that enough. Confluent Cloud is really the easiest way to get started with Kafka and streaming. So a little bit about their about the structure of Confluent Cloud. They're selling an open source product, right? And so some resources exist within this cluster, and then other things are like attached to the organization. And then we have like environments as a logical grouping in between. The stuff that's in the cluster is really Apache Kafka. Like anything that's happening here is something that you could probably migrate to another Kafka provider without a whole ton of effort. All of the other stuff is really like the parts of Confluent Cloud that aren't going to migrate anywhere else. So just kind of calling that distinction here that we have some like organizational level kind of cloud level resources and then stuff that is part of the kind of managed Kafka that they're selling. So the first thing I'd like to dig into is how we manage user access. Confluent Cloud's role-based access control is a little bit lacking if you're used to something like AWS or other places. Roles are predefined. So we have this organization admin, environment admin, cloud cluster admin. Each of those has access to everything either within the organization, within the environment, or within a cluster. There is this operator role, which is good in a lot of situations because it will allow people or services or whatever to allow to see configuration broadly. They can read all of the configuration details, no secrets, but they can go see that a topic's out there. They can see how much data the topic's moving. They can see kind of the basic configuration of that and so forth. And then finally, this developer read, write, and manage. This is ways to kind of enable some granular access on a per topic basis. So the way we've decided to apply this is essentially with a 3 environment setup. We have, it's probably very familiar to some. We've got a development environment that is a place for engineers to test out ideas quickly. There's this QA environment, which I always refer to as practice for production, and then there's production. So again, there's no other mechanisms here. We have to assign those kind of predefined roles to individual users. So each of our engineers actually gets a few more, but at least these 3 roles. So this is a very kind of simple access model. Every engineer can see every configuration everywhere. You can go look at your cluster in prod or in dev and see everything about how it's set up. The engineer gets cloud cluster admin on the development cluster. And so this is kind of their sandbox. They can go in the UI, create topics, do whatever they want to do right there in the UI without, codifying any of that work. And then finally, they get developer read on the QA environment. And this basically allows them to consume messages back out of topics and validate their outcomes in a pre-prod environment. And that's really the only difference between QA and production, is that you can go read the data in QA and you can't read the data in production. But this is still pretty complicated. You can imagine in the UI, if we're assigning 3 roles to every engineer manually, and then we decide, okay, we need a 4th role that is attached to every engineer. Well, that's a lot of work. Or there's a lot of opportunity to get that wrong. It's just a very kind of human error prone process. So Pulumi can be used here. The code you see over on the side here is pretty much literally copied out of the main config or the main Python file I have on this project I used to manage user access. And it just goes and loops through all the emails and manages the role bindings to give roles to those users. And like I said, this is just one way to really reduce the effort required to provision, deprovision, or adjust the level of access for individual users. So this is just a quick example of what that looks like, with actual code. This is a role binding. This is somebody getting the cloud cluster admin role assigned. This kind of user ID thing is used a lot throughout Kafka. You'll see that. So the next thing is naming conventions. This is another way in which kind of open source Kafka is a little bit different. It doesn't have any built-in mechanisms for tracking ownership or describing resources. It's literally all in the naming convention. Just recently, so this is just last month, the beginning of last month, Confluent Cloud introduced this stream governance feature that enables tagging, which is kind of closer to what you'd expect with resource tagging in AWS or other cloud environments. But that just came out last month. For the last 5 years, the rest of this is true. Naming conventions are really the only way to keep track of your Kafka resources. So I want to go over a couple naming conventions we've established here at Dutchie, and this is going to tie into understanding the way the monorepo is laid out a little bit later. So first, cluster naming convention. It's really simple. Each cluster has a purpose in a region. Right now, we just have one general purpose cluster in each environment, so they're all named common US East 1. But this naming convention creates space for us to have clusters that have really specialized purposes. and also to support multi-region deployments, which is something that we're definitely going after eventually. It's just not a this month thing. So the next one is the topic naming convention. So real quick, the first segment in that indicates if the topic should be consumed outside of its domain. This domain is just kind of an abstract concept of an ownership boundary. Just a little advice here, it really shouldn't align to a specific team or project. You should try to avoid any names that change. It needs to be a really durable name that's going to live with the data and kind of with the structure of the business for a long time. Subdomain just provides some additional structure in there. And then finally, data name, the last segment, reflects the actual subject matter of the topic. So this is just a quick example. This would be a topic that anybody could consume to understand product views that were collected from the e-commerce portal. So that brings us into the monorepo itself. So the high level monorepo is just like, it's just cramming a bunch of projects into one repository to reduce the overhead. So for us, that's a single GitHub repository with a bunch of Pulumi projects in it. Again, I'm just trying to minimize the amount of work that I have to do to support all of these people. So project ownership is managed by this code owners file. Anybody familiar with that is going to know that's just something that drives the approval process, like the pull request approval process. So that's what's going to allow an individual team to come in and make some edits to their Pulumi project, commit it, approve it, and get it sent out the door. All projects are deployed through this common workflow. Again, just trying to minimize the amount of effort I have to do to build and maintain all of this. There's this little hacky thing I do with the Python path so that everybody has access to this core module. And then that also allows us to just share one virtual environment. I considered a couple other options there, symlinks, or doing like giving each project its own poetry dependencies and treating the core as a local dependency. That's probably like the most proper way, but I found that it was there was a lot of friction moving between one project and another, and so ultimately I tried it out and took it back out because it was more work on a day-to-day basis. And yeah, this just simplifies everything. So a little bit about the organization here. Each project in this monorepo aligns to a single domain, going back to that topic naming convention and this kind of loose concept of an ownership boundary. Well, the names have to align to the name of the project. And then that is a really easy way for me to then understand who I need to talk to, because I can see what the name is, and then I understand there's a code owners file. I can trace that back to at least a GitHub group and understand some people to go talk to. And it also tells me, where in the code that resource might be defined. And then the other thing is each stack defines resources for a single cluster. And I think I heard the last presenter kind of comment something similarly, this like real simple straight up arrangement of one stack per cluster. It's what I've done here. And so what that means is users only have to create an appropriately named stack, and then the workflow selects a GitHub environment that pre-configures everything. And that stack name just really directly mirrors the cluster naming convention in the environment. So another way that I've helped here is by adding these thin abstractions to reduce boilerplate. So the Confluent Cloud provider itself is extremely verbose and like structured. So I've kind of built these thin abstractions. That's most of what's happening in this core module. These abstractions further benefit from the assumption that each stack targets a specific cluster. So I'm able to kind of automate a lot of the configuration there, so my users don't have to think about it. And so this is what it takes just to define an API key. I felt like I needed to demonstrate this. So there's a lot of nested objects that kind of, this owner is really just taking the service account, but in all its constituent parts assigned to other Well, no, that's exactly the same. And same here. So there's this kind of all this boilerplate that an engineer would need to understand. But when I look at this code in its entirety, the only thing that I need my user to provide me so that I can stand up an API key for them is the service account, right? And so that's really all these thin abstractions are, is taking this giant chunk of code and boiling it down to this so that my end user doesn't have to think about it as much. This still provides them the opportunity to break out of this abstraction. I've worked in some other situations where you know what I'm giving the engineers is essentially the Pulumi providers directly with a little bit of convenience on top. And I've seen other situations where that kind of is completely abstracted and they're just working in YAML. But again, I want to stay out of everybody's way. So I want them to have access to the full tool set if at any point I'm blocking them. So let's talk a little bit about the types of things these users are provisioning on Kafka or on Confluent Cloud. Again, kind of coming back to the structure here, most often users need to authorize services to read and write to a Kafka topic. So basically everybody that uses is going to need a service account, some ACLs, and API key. Then anybody that's going to be producing data is also going to want to provision their topic, and then others still are going to want to use these managed connectors, which really simplify integration with third parties and data stores. So the big challenge here is that our users need to deploy stuff at the organization level and stuff at the cluster level. And I'd considered service accounts, managing them in a separate project and using stack outputs. But again, just really leaning into simplifying this as much as possible for my end users. I wanted to allow them to define service accounts in the same project alongside their ACLs, API keys, topics, and connectors. Again, just trying to make things as low friction as possible, as simple as possible. So to do this, though, the workflow runner needs to be an organization admin. So basically, they need to execute code as a super admin. Obviously, that's a bit of a concern. Policy packs, though, have allowed us to do this safely. And basically, what I've created is a policy pack that just restricts creation to these 5 resources and then further ensures that these API keys aren't created for the admin service account or for other users. And that locks things down pretty well. That will prevent anybody from elevating their access or, standing up a new Kafka cluster or, going and deleting something, whatever. So this is just a little example of one of those policy rules. So this is policy enforcement for the, like I said, to ensure that nobody generates an API key for that admin service account. Retrospective here, I've only been running this for about 6 months. In that time, the Monorepo has grown to 6 projects with 15 stacks. We've stood up connectors and liberated data out of 2 of the 3 monoliths, and we've got 1 product feature rolling out into production. That product feature rolling out into production is, I guess, going back to my earlier points, it was nothing that was a thought in anybody's head when this work started. But again, focus on creating opportunities and then the use cases will follow. So some bumps in the road. I did end up building a dynamic provider. There was a situation where I needed to run a standalone Kafka connector, and both dynamic and providers have really unique execution environments that you should watch out for. And then the other thing is early adoption is just kind of tough. I developed a proof of concept 3 weeks before the 0.1 release of the official Confluent Cloud Pulumi provider, and have, expectedly bumped into a few hairy bugs along that upgrade route, being an early adopter. Let's see, looking ahead, some other things that I'd like to do with this project. I think that the Monorepo is only going to grow so far. It is, it's pragmatic choice. It's something we do to reduce friction right now. But eventually, I think that shared workflows and perhaps creating a shared, like a proper poetry library for people to import is going to enable more autonomy for teams. They'll take on a little bit more work, a little bit more responsibility in that, but they will have more autonomy. I want to try enforcing that naming convention that I spoke about earlier in the policy pack. This is something that has just occurred to me in the last couple of months that I could probably do that. So I think that's something I'm going to try. And then finally, this last one is a really a much bigger subject, but like I said, the dynamic connector, it doesn't work well outside of the main module, which means that it's kind of difficult to create a dynamic connector and then share it internally in your organization. Beyond that, topic schemas and KSQLDB queries are also things that have really conventional REST APIs behind them that don't have providers today. And I have a feeling that I know at least the top two and maybe the third is something that I'm going to be tackling in the next quarter. And that's it for me. I didn't see any questions throughout, but oh, I missed the question side. Can you use No, I think that's somebody else's questions.
That's previous. I'll ask you a question, Tom.
Cool.
I think you talked at the beginning of your talk with a question that a lot of us wrestle with in a lot of different ways, where there is an OSS version of the technology, in Kafka, and you sort of have to decide, hey, there's this cloud version, it's easy to use. We often get asked, should I self-host Pulumi or should I use the service version of Pulumi? How did you sort of think about the trade-off on, should I burn an engineer, standing up the instance versus the cloud service, and how do you think more generally that sort of trade-off, with using OSS versus the managed version of the service?
I think, well, I mean, it really is going to depend on the appetite of the organization. I think, a really technology-led organization might just inherently understand the value of the technology, and they're going to put a lot of engineers towards doing something like that. But more product-led orgs are probably going to be a little bit leaner on innovation like this. The benefit is not as well understood. And so we basically need to find, like right now, solutions that don't require a lot of engineer time. And that was basically what drove the decision here. Yeah.
Yeah, cool. I think you also talked a little bit about the challenge overall between unifying platforms, whether it's from acquisition or heritage code base to modernization. Were the challenges mostly cultural or technical or a combination of both, or sort of how do you encourage people to move to the new platform, and what are your carrots?
Yeah. Well, it's been an interesting situation. So I started as part of this core technical services team and was kind of there at the beginning of it. So, and this was shortly after the acquisition. So we kind of came in as like a neutral third party to all of it. We weren't part of Dutchie that acquired. We kind of came in after Dutchie acquired the other organizations. But I would say, like, yeah, definitely culture is part of it. And but I would say that the real concrete problems are just operating multiple cloud providers, operating multiple technologies. We have Ruby and we have .NET, we have Azure and we have AWS and Heroku, and that's just a lot of overhead. And so really on one hand, one of our biggest things is trying to consolidate that effort, but also from our users, it's not the greatest experience. They still log in over here to go to a point of sale, and they still log in over here to go to an e-commerce admin portal. So I think the really unique thing about being in the position between those three is trying to figure out which aspects of the business we need to unify in a service first. Like, what does that look like?
Yeah, that's awesome. Well, Collin, I really want to thank you for your time. It was awesome getting a little bit behind the scenes view. I know you got a lot of challenges, and all of us as providers to other folks in the organization are constantly swamped with requests. So thanks for making time for us.